Hello everyone. In this video we are going to demonstrate the mix design for M25 grade of cement. To design the concrete mix, first we have to find out the specific gravity of fine aggregates and coarse aggregates. To determine the specific gravity of fine aggregate, a clean dry pycnometer is taken and its empty weight should be determined, and take this weight as W1. Now add about 500 gram of clean sample into the pycnometer and determine its weight as W2. Add water to the pycnometer till the hole at the top along with the aggregate sample and take this weight as W3. The content of the pycnometer are now discharged and cleaned. Now the water is filled up to the pycnometer without any entrapped air and take this weight as W4. Using the formula, specific gravity of fine aggregates can be determined. To find out the specific gravity of coarse aggregate, first take the weight of oven-dried aggregate as W4 and weight of the basket suspended in water as W2. Wire basket is then immersed in water and take the weight of saturated aggregate suspended in water with basket as W1. After the basket is jolted for 25 times, take the basket and aggregates out of the water and dried with dry absorbent cloth. Take the weight of saturated surface dry aggregate in air as W3. Using the formula, find out the specific gravity of coarse aggregate. So the next step is to find out the specific gravity of cement. The apparatus required to find out the specific gravity of cement are Le Chatelain's flask or specific gravity bottle, weighing balance, kerosene that is free from water. So the first step is to weigh the dry specific gravity bottle and take this weight as W1. Next, fill the bottle with water to the top and then take the weight and take it as W2. Remove the water, dry the bottle, fill it with kerosene and weigh this as W3. Pour some kerosene out and introduce a weight quantity of cement into the bottle and roll out the bottle gently to remove the air bubbles. Now fill the bottle to the top with kerosene and weigh it as W4. And the mass of the dry cement should be taken as W5. Using the formula, find out the specific gravity of cement and also kerosene. Specific gravity of any cement ranges from 3 to 3.15. Next step is to design a mix proportion using IS 10262 2019 and find out the target strength for mix proportion, approximate air content, water cement ratio, water content, cement content and volume of fine aggregates and coarse aggregates, and do the mix calculation for 1 meter cube of volume. Since we are casting for 6 cubes, take the ratio of all the cement and fine aggregate and coarse aggregates and find out the new cement content, fine aggregate and coarse aggregate contents and the water required. First, collect 31 kg of 20 mm coarse aggregates by sieving. Collect 16 kg of fine aggregates. Collect 10.5 kg of cement content. After collecting the required quantity of materials to prepare the 6 cubes, dry mix the cement and fine aggregates first and then add coarse aggregates to it and mix it thoroughly. To cast 6 cubes, we required 5.04 kg of water. Now start adding the water to the dry mix and obtain a uniform concrete. Fill the cube molds in 2 layers by giving 35 blows for each layer. After filling these molds, keep these molds in a moist condition for 24 hours and then put it in a pond curing. Curing of these concrete cubes is crucial process in the field of construction because it affects the strength and also durability of the concrete structures. It prevents the loss of moisture from the concrete and it is crucial in the early stages of concrete setting and hardening. It also involves controlling the temperature of concrete to prevent the thermal stresses that lead to the cracking. There are different methods of curing, that is water curing, membrane curing, steam curing and covering with wet materials. So here we used pond curing, that is water curing. After curing, concrete cubes are often tested for compressive strength. This test is typically done at specific intervals such as 3, 7, and 28 days after casting. To access the development of concrete strength over time, the cubes are placed in a compression testing machine and force is applied until the cube fails, with the maximum force applied being recorded as the cube strength. Then, the compressive strength of the material is calculated by dividing the maximum load at failure by cross sectional area of the specimen's face that was subjected to the load, and the result is expressed in the units of force per unit area.